Welcome all to the class of Bioinorganic Chemistry. Here we will be discussing the role of inorganic elements in the biological systems. Let's move on to the first topic, the emergence of bioinorganic chemistry as a discipline. Here we will be discussing the sequential discovery and identification of different elements which are of biological importance. And we'll also discuss the emergence of bioinorganic chemistry in the late 1950s. Alchemy was a mixture of science, philosophy, and mysticism. During their search for the philosopher's stone, the alchemists had accomplished many important scientific discoveries. In 1669, Henning Brandt, a German merchant, a pharmacist, and also an alchemist, isolated phosphorus from distillation of urine. Phosphorus is the sixth most abundant element in the human body. It's also the seventh most abundant element in the Earth's crust, whereas in seawater it is the 18th most common element. Next, in 1746, the importance of element iron and its association to blood has been conclusively proved by Vincenzo Mengoni, who showed that the dried blood sample actually attracted to a magnet. Iron is the first transition metal to be identified as having of any biological function. The ancient Chinese had recognized goiter and the therapeutic effects of burnt sponge and also seaweed in reducing its size or causing its disappearance. In 1811, iodine was discovered by the French chemist Bernard Courtius, and the modern use of iodine in prevention of goiter dates from 1830, when it was proposed that goiter is an iodine deficiency disease. Before 1800, there were only 36 elements that had been discovered. The next 50 years added 22 more elements, mainly from the impulse from scientific revolution and atomic theory, and also industrial revolution. A knowledge of elements and their characteristics began accumulating during this period of time. Zinc is an indispensable element to all forms of life. The first demonstration of the essential importance of zinc for the growth and development of living organisms dates back to 1869, when the requirement of zinc by filamentous fungus, Aspergillus niger, was shown. However, a precise biological function of zinc was discovered only in 1940, when it was shown to be necessary for the catalytic activity of carbonic anhydrase by Kaelin and Mann. After its establishment in the enzyme, the discovery of zinc-containing enzymes outnumbered every other element in the periodic table. It is presently present in more than 300 enzymes, comprising of all the 6 categories of enzyme. It is also the second most abundant transition element in the human body. The discovery of Rowling paved the way, paved the problem of trace elements. Hints that copper plays a vital role in living systems came when in 1816 Eisner discovered that the ash of plants contained the element. This was followed by the identification of copper in a number of foods and later in the blood of snails by Harless in 1847, leading eventually to the discovery of oxygen carrier protein hemocyanin. Evidence of an essential need was established, however, in 1927 by J.S. McHugh, who found that plants and animals need copper for optimal growth and health. The transition element molybdenum is of essential importance for nearly all biological systems as it is required by the enzymes catalyzing diverse key reactions. The metal itself is biologically inactive unless it is complexed by special cofactors. Eugene Cornet demonstrated the spectrum of molybdenum in seaweeds along with 17 other elements, but it was in 1932 Termeulen obtained molybdenum from the coal ash that a conclusive evidence of molybdenum is obtained. He later found that azolla contains more amount of molybdenum. It is the only transition element which belongs to the 4D transition metal series. The disease pernicious anemia was first described in 1821 and was an invariably fatal disease. In 1926, George Minot and William Murphy discovered an effective treatment of pernicious anemia with liver concentrate, which was high in vitamin B12, later identified. In 1947, Focus, the director of Merck Research, isolated vitamin B12, producing the tiny bright red crystals of vitamin B. It was then later crystallized and characterized by Dorothy Hawke, contributing to her Nobel Prize in 1964. Manganese is an essential micronutrient in most organisms. More than 200 years ago, the presence of manganese in leaf tissues of plants was experimentally documented. The probable role of manganese in oxygenic photosynthesis was demonstrated for the first time by Person and his co-workers in 1937. They recognized that plants and algae are unable to release oxygen in the absence of manganese in their growth medium. In 1954, Vincent discovered that Escherichia coli produces gas from formic acid only when the medium is supplemented with trace elements molybdenum and selenium. Escherichia coli was the first organism for which the biological role of selenium was demonstrated. It took almost 40 years to identify the enzyme responsible for the formate oxidation under the aerobic conditions used by Vincent. It is now known as the formate dehydrogenase 0 enzyme. Selenium mainly present in the form of selenocysteine, the 21st amino acid. The field of chromium biochemistry started in 1955 when Mertz and Schwartz fed rats with yeast-based diet, which resulted in the rats apparently developing impaired glucose tolerance in response to an intravenous glucose load. Shortly thereafter, a dietary factor, selenium, was discovered, which could reverse the liver disorder but not the glucose intolerance. Thus identified a new dietary requirement absent in the yeast-based diet and responsible for the glucose intolerance, which they coined glucose tolerance factor GTF, which later identified contained chromium. The beginning of the present flourishing in the bioinorganic world may be dated back to the late 1950s and to the early 1960s, when the X-ray structures of hemoglobin and myoglobin were solved by the illustrious chemists Mark Perutz and Jesse Kentrew. In the 1970s, a significant share of inorganic chemists entered the field, which has been steadily growing since then.